This video is to demonstrate the difference between materials that are used in different systems for delivering ozone. Typically, everybody uses silicone. What we use is PTFE because PTFE is totally resistant to ozone, whereas silicone breaks down. Evidence of that is typically what is found in generators. It yellows, it becomes brittle, it becomes stiff, and then it breaks and they leak. Every silicone appliance that is exposed to ozone will do the same thing. It's just a matter of time. So some manufacturers are switching over to Teflon. We actually take this instrument, it has a silicone tubing in it, we replace it with Teflon inside, and so we have a instrument that's going to last a long, long time without any failure. It basically puts out about 120 micrograms per milliliter. We're going to be comparing Teflon tubing. This is 1 millimeter diameter, which is more than adequate. It'll handle up to 1/2 liter per minute, which is more than adequate. Comparing it to what's typically sold by manufacturers, 4 millimeter silicone tubing. These are the exact same length. And so we're going to use them. We're going to use our balloon as an example of bacteria, if you will, that's being destroyed by ozone. It's a lipoprotein similar to the bacterial cell wall. So let's go ahead and do this. We'll start with PTFE tubing, and we'll connect it to our generator. Generator's oxygen is on, 1/32 liter per minute. This is open, and we're going to connect this to our subject. And what we're going to do is turn on the generator, and then we'll see how long it takes for the ozone to get to the balloon and pop it, so it gives you an idea of what destruction. Let's just reset this here so we zero it. And we'll start our clock. And it's zeroed, and we're going to, it's plugged in, it's on, it's not turned on yet. So we're going to go ahead and time how much time it takes to get from here to the balloon, and then we're going to be measuring the peak when it does get there. So let's go ahead and 1, 2, 3, start. 4.6 seconds. Now let's find out what the concentration is. It's zeroed. So let's take our tube here and connect the analyzer. It's connected now, and you watch how fast it does start measuring. It's because it's ozone is delivered in 5 seconds. So we're at 125. We'll call it 125. Turn off the generator. Let it flush out the tube. 125. Keep our clock going here. That's zeroed out. This is almost zeroed out. Like a couple more seconds here. We'll get our next one ready to go here. We can't do anything until we do that, so we're good. Okay. Take this off. This off. We're going to compare now to the silicone tubing. Same generator, same standard. 1/32 liter per minute. Different subject. Okay, and we're going to do the same test. Let's zero this out. Get our clock on. And we're close enough there, let's do that. Okay, so 1/32 liter per minute, and we're gonna go ahead and see how long it takes to deliver the ozone to the subject here. Starting 1, 2, 3. Now remember, it's a larger diameter, so by design, it's going to take a lot more time just because the diameter is so much more enlarged. But it also is silicone material, which breaks down. If it breaks down, that means ozone is being used up as it's traversing slowly through this tubing, and it end up delivering a much lesser concentration. We'll see that in a minute. Key is, everybody knows what their generator is putting out. It's always printed on them or it's in their documentation, but you do not know what's being delivered to the patient, and you do not know how long it takes to get to be delivered to the patient. And so, go, time, set, stop, 45 seconds. Now let's measure the concentration. Attach it to our analyzer. Let's reset it. Okay, I'm going to put this on. Now, because the tube already had ozone in it, it's going to start registering quicker, but we'll wait for it to stabilize at its peak. So 76 point, let's call it 76.4. And let's clean that out, let the oxygen flow through there. And the next thing is, we're going to talk about air insufflation devices. There are basically, this is what you buy when people sell you a modified stethoscope ear insufflation device. It's significantly different than a device that's designed specifically for using ozone. So basically, this is a modified stethoscope. In this case, it's an aluminum hoop. It's got some kind of a plastic ear tip that's meant to seal. You do not want it to seal. It doesn't, and so they use cotton between the ear and the instrument so it won't form a seal. That's just another separation of ozone from the ear, and it gives it even less potency as well as less concentration. So seals, and then the ozone is delivered through the aluminum and then through a large diameter silicone, so that we're comparing apples with apples. We'll show you that they're the exact same length. The difference is in the design. Now with a modified stethoscope, we just went through those details, but with an instrument designed specifically for delivering ozone, you have Teflon earbuds. Teflon is totally 100% resistant to ozone, and it's delivered through a very small orifice, a 1 millimeter diameter in there, coming from a 1 millimeter diameter tubing that goes inside the silicone here, and it comes out here, and this is our feeder line. Again, 1 millimeter diameter, same length as the other. Now, the other unique feature with this is that we have disposable tips, so it's more hygienic. The buds themselves do not seal, they cannot seal. And as the ozone goes in and comes back out, it's picked up by these 4 portholes on each one of these buds, and it's such, the vacuum is sucking it into there through the aluminum or through the metal tube, through the silicone, and it goes out to another tubing that goes to a destructor and muffler and vacuum pump. So it's completely different. This is designed for insufflation of ears. This is simply a modified stethoscope that is a poor excuse. So let's test both of these, starting with the modified, with the ear instrument manufactured for making ozone. Let's get another subject here. Do this and this. Okay. And okay. And we'll connect our tubing here. We've cleaned out by now, so let's go turn that off. Take this off. And we're turning on to 1/32 liter per minute. This can be disconnected. Eliminate this mark. Okay, so we're basically, and we just reset this here. And set our clock and reset. So our clock, air installation's in position, and we're going to do the same thing. Oxygen is 1/32. We'll turn on the generator and the clock at the same time. 1, 2, 3, go. And we'll stop it when it pops. 5.77. Notice how rapidly it delivers the ozone. 5.77. Now let's find out what the concentration is. We're zeroed. Let's go from here, turn this off. Oh, we can leave it on. Oh yes. We've got a yoke here, and the yoke fits on the buds. Okay, and that goes into our analyzer. And let's see what the concentration should take about 7 or 8 seconds to get to a concentration full. There you go. So we're at 116. Let's turn on the oxygen. 116. Now let's remove that. See, let it clean out. That's good enough. Let's go back to 1/32 liter per minute. Remove that. And tips here. So let's test for that one. Now let's do a modified stethoscope. And our last subject. Screw around there. Okay, we're at 1/32 liter per minute. Oxygen's on. Set our clock. Reset. And let's push same time. 1, 2, 3, start. Confirm we're at 1/32. Okay, we're good. Remember, it takes much longer because it's larger diameter. In addition, it now has more length because of the stethoscope is added to it. So we're comparing apples and apples. The air insufflation instruments designed for air insufflation and a modified stethoscope. Now, depending upon your equipment and what you use, what you use it for, you must be looking at your tubing. It is absolutely imperative that you see your tubing, both length and diameter and material, because you don't know what's being delivered. You only know what the generator is putting out. So we're at 40 seconds. We'll reset this one. Okay, 1 minute, 2 seconds. 1:02. Now let's find out what the concentration is. We'll connect this to our instrument here. It already has some ozone in it, so it's going to see. Let's wait till it stabilizes. call it 88. Turn off generator, clean out the tube. Okay, so the differences are very profound. If you're comparing silicone tubing to PTFE tubing, the PTFE put out 125 micrograms per milliliter, silicone 76.4. It took 45 seconds to traverse for the silicone tubing versus 4.65 seconds to traverse the PTFE. Then we come to the instrument that is designed for insufflation using Teflon. Took 5.77 seconds to deliver 116 micrograms per milliliter. And with a modified stethoscope, it took 1 minute and 2 seconds. That's 6 times longer. And the concentration was significantly less, 88 versus 116. So please consider when you are applying instruments and tubing and materials for your patients, you must be using the best, and the only best is Teflon tubing because it does not break down. Otherwise, you have no clue what's being delivered to the patient.